Hi, welcome to this podcast on the installation phase of the system's lifecycle for OCR Computing A-Level, Unit F451. So the installation phase is pretty much as it says. This is where, once we've decided that solution is okay, it's been tested and everything's been accepted, it's now to be installed in the place it is to be used. So in the usual examples you will get, it will be in a business scenario. So we've got to plan the installation. We need to set up a suitable method of installation. So we've got different types of installation methods. We've got parallel running, pilot running, direct change and phase changeover. We'll look at each of those in a moment. We need to ensure the correct hardware is available that is being bought, installed or commissioned. So all the correct hardware is in place. We need to install the software on the new hardware, on the hardware that is there. We need to arrange for staff to be trained in use of the new system. And possibly write training materials for them. We need to input data to the data files either manually or by downloading from the original system or old system. We need to test the system with real data and use real users. And then we need to monitor for errors and provide technical documentation for people to be using the system and to correct any errors that are taking place. So you could get a question on this. So what do you need to plan for installation? There's a variety of answers there. Any of which would be perfectly acceptable. So if we have a look at the method of installation in the workplace, the first one we'll look at is parallel running. Right, until the system is fault-free, the old and new systems are run side by side. Positives of this is it allows the results of the new system to be compared to ensure there is no problem. So the new and the old system are compared with each other and make sure there's no problem. This is safe and allows staff training to be carried out. So it's safe because we can allow staff training to be carried out at the same time, and if a mistake does happen, we've got the old system there in place. And if there are any others, the old system is still in place, so it shouldn't be an issue. Negatives, though, are it's very expensive, as everything has to be done twice. Think we have to input the data twice to the system, we have to run the reports twice from the system, and so on. So that's a negative. When is a suitable use for it? Well, this can be used when the data is so valuable there must be no possibility of failure. So a situation where you have to have something working and you can't have any failure at all. So it might occur in certain hospital systems where you do parallel running, maybe a heart monitor or something like that. Right, pilot running. This is where the software is fully installed but only in one area of the organisation. For example, one branch of a supermarket. Tesco's, Old Swan for example, might get the installation of a new system, but every other Tesco in the country keeps their old system in place. This means that it can be run in a real situation to help spot errors. Staff could be trained on a rolling programme, e.g. staff are sent to work with a new system in this branch for a week. Any major faults will only affect one branch of the business. The negatives, though, is if there is a major fault, that branch is potentially crippled. So if there is a major fault, that could send the whole branch down. And organising a rolling training programme could be difficult to organise. All right. So we've got positives there, but then the positives are also negatives as well in some respects. The fact that we've only got one branch is good in a way, but because it's pilot running and that one branch is totally changed over, then there is the risk that branch could potentially go down if the system goes down. The next one is called direct change. Again, quite obvious when you think about it, or big bang is what it's described as well. The old system is removed and is replaced completely and immediately. Everything is swapped over straight away. Direct change, big bang, boom, it's done. This allows a quick changeover to the new system, so speedy, quick changeover. Problem is, you might see a decrease in efficiency. Staff have to learn while on the job, so we might see a loss of money initially. If something goes wrong, it's catastrophic. It could be catastrophic, but something goes wrong, the whole company could go down. It could be disastrous for the company. Last one, again, quite common sense when you look at the title, phase changeover. Some tasks previously performed by the old system are replaced with a new system. As confidence grows in the new system, more and more tasks are undertaken by the new system until eventually the old system can be completely replaced. So we only do little parts at a time. So phase changeover, we do first phase, second phase, third phase, so on, so on, so on, however many times we think we need to do it. This allows some testing the new system to be done, which is good, a gradual increase of the changeover. The staff training can take place in chunks and allows for a backup position if new version doesn't work as anticipated. So because it's phased, it's a bit better in some respects. Generally, you won't be asked, I don't believe you'll be asked questions on which type of changeover is best. You might get one like that. The likelihood is a question's probably going to ask you what do you need to plan for an installation, or it might ask you to describe one of the 4 different types of installation methods that we have just described there. And that's it for system maintenance.